At times in the past, whenever a machinist wanted to produce a part, whenever a part had to be made, every motion that the machine made had to be caused by the machinist. So the machinist would take a look at a print. In his mind, he would convert those details on the print over to a plan that would enable him to make the part. And included in that plan would be all the different motions that the machine would have to carry out in order for that to happen. All of those motions had to be made by the machinist himself. So the machinist was actually the computer. If you think of it in terms of a modern CNC machine, the machinist was both the computer and the motor for the table, the drive motors. So the machinist would actually have to perform all the operations manually. And all the input occurred from the machinist watching the dials to figure out exactly what position the cutter was at. In the early 1980s, the idea came about that, hey, with computers, we can actually control motors using computers. And so the first CNC machines actually used a punch tape to input information to the computer, and then the computer controlled the actual motors that drove the machine and actually made the cuts. So what we had then was a transformation, and the transformation was that now it wasn't the machinist who was turning the motors, it was information that was turning the motors, and the machinist just had to get the information in the machine. And once the machine had the information, then it was able to carry out instructions automatically while the machinist just watched. And at that point, the machinist really became a programmer rather than an operator. So the machinist would formulate instructions to put into the machine. Let's say G01, Z10 with a feed rate of 5. Alright, and so that simple line of code is enough to cause the machine to operate. It became known as G code because most of the instructions that were used to program the machine started with a G. And so that is how G code got its name. So machining was at a point then where we had motors and motor controls that could precisely position the machine, and we had computers that were able to feed the information to the motors and the motor controls so that the machine positioned itself according to the machinist plan or according to the machinist's instructions. And so we had a situation where, again, the machinist became essentially a programmer, or a programmer who happened to understand all the important aspects of machining. At roughly the same time, there was something else going on. And that something else was that CAD systems became available, computer-aided drafting. And what we mean by that is that rather than drawings on a sheet of paper, we were putting drawings into a computer. Well, at first, all we did was just transfer the same lines that we had been drawing on paper, and we put those on a computer. And as computers and operating systems and speeds for the computer got better, it became possible to actually do a whole lot more than just draw lines on the computer. As CAD systems got better and better, it became possible with better and better processors, better operating systems, faster computers, to create software that would actually do more with CAD than just allow us to transfer the lines off of paper onto the computer. We could actually build 3D models that served a lot greater purpose. So at that point, which really didn't come of age until probably the 90s or early 2000s, then it began to dawn on people that, well, we've got CNC machines that operate using information as input, G-code programs, and we have CAD systems that can create models of the parts that we want to build. And what if we could take the CAD models and use the computer power to create G-code programs that could be used on the CNC equipment? Well, today we've got exactly that. And what ultimately we'll be learning in this class is to use a software program called Mastercam. And what Mastercam allows us to do is to actually use the model and tell Mastercam what machining operations we want done here, and it will actually result in a finished G-code program. Now, to begin with, for an intro to CAD course, it's probably a little bit too much to start with Mastercam.
As a result, I chose to ask you guys to download a program called CamBam. CamBam is an open source piece of software that's available free at no cost on the internet. And what it allows you to do is perform both the CAD, the drawing portion of the process, and the CAM portion, part of the process, which is converting the drawing to G-code. So what I was hoping that you guys could do is to do something really simple, like this, for instance. Choose a circle. Place that circle somewhere on the screen. And then you can go into the machining tab and actually create the G-code from that profile. And once the G-code's created, you could save it to a file on your desktop and submit that as your assignment. In this case, we'll label it as myproject.nc. Okay, and then after you've asked the machine to produce the G-code, you can go back into machining and ask to take a look at that G-code. Machining. Now we're going to go to Edit G-code. And you can see the program that's been created there. But that's the code that's required to cut that circle. However, I failed to take into account that many of you would have trouble with the installation of CamBam. And with so many operating systems, some of you have Chromebooks and that sort of thing, and so it didn't work for everybody equally. So that left me with some rethinking to do. What I realized was that you guys needed some way to access software that was simpler than Mastercam, at least until you get started, but which didn't have to be installed on your computer like CamBam. And so the solution that I'd like to recommend to you is actually a website. Okay, so what I'm going to suggest now is that you go to a website called makercam.com, makercam.com. Now, what makercam.com is a program that works a whole lot like CamBam, except that it works through your browser and doesn't have to be installed on your computer. So it should work whether you've got a Chromebook or a Mac or anything else. So it shouldn't matter what computer you have, and you should be able to make it work regardless. So the first thing that I'm going to suggest that you do as an assignment is to work through the tutorial. And in the upper right hand side of the screen, you'll see that there's a link for the tutorial. And the tutorial will bring up some instructions for you to get started using MakerCam, and it'll work you through step by step through a little project and will allow you to create some G-code. So what I'm going to ask you to do is to work through that project and submit that G-code as your assignment. I will open up that first assignment and change the due date so that you could submit your first assignment from MakerCam rather than CamBam. What you'll end up doing is submitting to me the G-code program that's produced when you go through this tutorial on MakerCam. I want you to follow through that tutorial, go all the way through the step which is titled Preview G-code. So go ahead and preview your G-code and make sure that everything works out correctly. That's the way you'll know whether your G-code file was correct or not. And do not worry about going to the set up your work area step, because that concerns setting up the CNC machine in order to actually produce what you've drawn up and what you've created G-code for. What I will do is, after you guys submit your file, I'll pick one of those files from one of you, and we'll actually produce that part and post the video of it so that you know what it's all about. Hope this helps. I think this will work out a whole lot better than CamBam, and sorry for the delay.